Imagine staring into the infinite abyss of space, where billions of stars burn with secrets older than time itself. Each one, a cosmic furnace, blazing with stories of creation, destruction, and mystery. For centuries, humanity has gazed upward, charting constellations, discovering distant worlds, and dreaming of what lies beyond. Telescopes like Hubble, Kepler, and the James Webb have peeled back the curtain of the cosmos, revealing millions of stars, each with its own rhythm, its own pulse. But among this galactic symphony, one star, 1,400 light-years away in the constellation Cygnus, sings a song so strange, so haunting, that it's left astronomers, scientists, and dreamers alike speechless. This is no ordinary star. This is a celestial enigma that defies everything we thought we knew about the universe. Buckle up, because we're diving into the most shocking, mind-bending discovery in modern astronomy. A star that's rewriting the rules of the cosmos and sparking whispers of something otherworldly. It all began in 2015, when a group of passionate stargazers, combing through mountains of data from NASA's Kepler Space Telescope, stumbled upon something bizarre. Kepler, launched in 2009, was humanity's most ambitious planet-hunting machine, designed to stare at over 150,000 stars, searching for the tiniest flickers of light that might betray the presence of an orbiting world. Its mission was simple yet profound: to find planets, maybe even Earth-like ones, hiding in the glow of distant suns. And it succeeded beyond anyone's wildest dreams, discovering over 2,600 exoplanets, worlds of fire, ice, and gas, orbiting stars far beyond our own. But this one star, catalogued as KIC 8462852, wasn't playing by the rules. Its light wasn't just flickering, it was screaming. Picture this: a star, roughly 50% larger than our sun, burning steadily for billions of years. Suddenly, its brightness plunges, not by a fraction of a percent, like a planet passing in front of it might cause, but by a staggering 22%. That's like the sun dimming so much you'd notice it with your naked eye. And it wasn't a one-time event. The star's light would dip dramatically, sometimes for hours, sometimes for days, with no predictable pattern. One moment, it's shining as expected. The next, it's as if something massive has swallowed a fifth of its light. Astronomers had seen stars dim before. Planets, dust clouds, even stellar hiccups can cause it, but nothing like this. The dips were too deep, too erratic, too wrong. And that wasn't even the half of it. When researchers dug into historical records, they found something even more unsettling. This star had been slowly fading for over a century, losing brightness at a rate no star of its age or type should. It was as if something was draining its energy, siphoning its light like a cosmic vampire. The internet exploded, forums buzzed with speculation, scientists scratched their heads. Was this a glitch in Kepler's instruments, a cosmic prank, or, dare we say it, evidence of something far stranger? The star, nicknamed the WTF star, yes, that's a real scientific term from a 2016 paper titled "Where's the Flux?", became an overnight sensation. It wasn't just astronomers who were captivated. The world was watching, waiting for answers. Because when you strip away every natural explanation, when you rule out the impossible, what's left, no matter how improbable, starts to feel like the truth. And the truth might just be out there. Let's start with the basics. Stars don't just dim for no reason. Their light can flicker due to internal processes, like pulsations in their cores, or external ones, like a planet crossing their face. But planets cause tiny, predictable dips, usually less than 1%, and they happen like clockwork as the planet orbits. Even a gas giant, like Jupiter, would only dim a star like this one by a single percent. To cause a 22% drop, you'd need something absurdly huge, far bigger than any planet could ever be. There's a hard limit to how large planets can grow. Beyond about 13 times Jupiter's mass, the pressure in a planet's core triggers fusion, turning it into a star or a brown dwarf, a failed star that glows faintly in infrared. But here's the kicker. If a brown dwarf were blocking this star, we'd see it in our telescopes. We don't. So strike one, no planet, no brown dwarf, no dice. What about dust? Young stars are often surrounded by swirling disks of dust and gas, the raw materials of planets and moons. These protoplanetary disks can block light, sometimes significantly, but this star isn't young. It's a mature, middle-aged star, billions of years old, far too old to have a dusty nursery still hanging around. Plus, protoplanetary disks are warm, glowing in infrared. If one were there, we'd see it. We don't. Strike two. Maybe comets. A massive swarm of comets could, in theory, block enough light to cause these dips. Picture hundreds of thousands of icy wanderers, each trailing tails of gas and dust, weaving in and out of the star's light. It's a wild idea, but it was the best guess in that 2016 WTF paper. The problem? To block 22% of the star's light, you'd need a comet swarm so enormous it would rival the mass of several planets. That's not just unlikely, it's borderline impossible. And comets wouldn't explain the century-long dimming. A swarm that big would have dissipated or been swallowed by the star long ago. Strike three. By now, astronomers were running out of ideas. Every natural explanation, planets, dust, comets, fell apart under scrutiny. The star's behavior was too extreme, too random, too unprecedented. And that's when someone dared to ask the question no scientist wants to touch. What if it's not natural? What if this star's bizarre behavior is the work of aliens? Yes, aliens. It sounds like science fiction, but hear me out. In 1960, physicist Freeman Dyson proposed a mind-blowing idea. An advanced civilization, desperate to harness its star's energy, might build a massive structure around it, a megastructure called a Dyson sphere. This isn't a solid shell, but a swarm of solar panels, satellites, or even artificial worlds orbiting the star, capturing its light to power a galactic empire. If such a structure were partially built or unevenly distributed, it could block the star's light in irregular, unpredictable ways, just like what we're seeing. The idea was so compelling that astrophysicists began to take it seriously. In 2015, the SETI Institute, yes, the Search for Extraterrestrial Intelligence, pointed the Allen telescope array at the star for 2 weeks, scanning for radio signals that might betray an alien civilization. The results? Silence. But that didn't rule it out. A civilization advanced enough to build a Dyson sphere might not use radio waves at all. They could be communicating with lasers, quantum signals, or something we can't even imagine. The media went wild. Headlines screamed alien megastructure found and proof of extraterrestrial life. The star became a global obsession, a symbol of humanity's deepest hopes and fears. Are we alone? Or is this the moment we've been waiting for? The first tangible evidence of intelligent life beyond Earth. For a while, it felt like anything was possible. But science doesn't thrive on hype. It demands evidence. And in 2018, A groundbreaking study, funded by a Kickstarter campaign, brought us back to reality. Or so it seemed. A global network of telescopes watched the star 24/7 for a year, capturing every flicker, every dip. The results were astonishing. Whatever was blocking the star's light wasn't a solid object like a planet or a megastructure. It was scattering light, unevenly blocking shorter wavelengths, like blue light, more than longer ones like red and infrared. This is a telltale sign of dust, trillions of tiny particles, finer than grains of sand, floating in space. A solid object would block all wavelengths equally, but dust plays favorites, scattering blue light while letting red light slip through. It was a crushing blow to the alien hypothesis. No Dyson sphere, no galactic empire, just dust. But wait, hadn't we ruled out dust already? Yes, but this wasn't your typical protoplanetary disk. This was something different. Cold, diffuse, and incredibly fine, spread out in a vast cloud. Unlike warm dust, which glows in infrared, this stuff was invisible to our telescopes. It could explain the deep, irregular dips and even the century-long dimming if the cloud was slowly growing denser. Case closed, right? Not so fast. If it's dust, where did it come from? And why is it behaving so strangely? One jaw-dropping theory suggests the dust is the wreckage of a cosmic catastrophe. Picture this. Millions of years ago, a planet on a wild elliptical orbit got too close to the star. The star's gravity tore it apart, shredding it into fragments. One of the planet's moons survived, trapped in a tight orbit around the star. Now that moon is slowly evaporating, its surface vaporizing into a colossal trail of dust and debris. This could explain the short-term dips as the dust passes in front of the star, and the long-term dimming as the dust cloud grows. Computer models back this up, showing how a kidnapped moon could produce exactly the kind of light curve we're seeing. It's a wild, almost cinematic story. A star devouring a planet, a moon fighting for survival, and a cloud of cosmic ash as the only witness. But there's a problem. Catastrophic events like this should produce heat. Lots of it. If a planet was ripped apart, or a moon is evaporating, we'd expect to see an infrared glow. We don't. It's as if the universe is hiding its tracks. And there's another issue. Events like this are vanishingly rare. The odds of Kepler catching one in a sample of 150,000 stars are like winning the lottery while being struck by lightning. With 100 billion stars in the Milky Way, there could be millions of similar events, but astronomers think that's unlikely. So either we got insanely lucky, or the theory's wrong. Another idea flips the script entirely. What if the dust isn't orbiting the star at all? What if it's floating in interstellar space somewhere between us and the star? A massive, irregular cloud of dust, drifting through the void, could block the star's light in unpredictable ways. If the cloud is getting denser over time, it could explain the century-long dimming. It's an elegant solution, tying up all the loose ends, except one. Recent observations suggest the star's dimming events might follow a rough cycle, repeating every 4.5 years. If the dust were in interstellar space, unrelated to the star, we'd expect no pattern at all. Plus, a cloud that big should affect other stars nearby. It doesn't. Only this star is dancing to this strange cosmic beat. So where does that leave us? As of 2025, the scientific consensus is that dust, some kind of dust, is behind the star's bizarre behavior. But the details remain maddeningly elusive. Is it the remnants of a destroyed moon? A cloud in interstellar space? or something we haven't even thought of. The James Webb Space Telescope, with its unparalleled infrared vision, has been tasked with studying the star, searching for the faint heat signatures that might finally solve the mystery. Early data is promising, but inconclusive. The star continues to tease us, its light curve a cosmic riddle with no clear answer. And yet, even with dust as the leading suspect, the alien hypothesis refuses to die. Could an advanced civilization have engineered a swarm of dust-sized nanobots orbiting the star to harvest its energy? It's a stretch, but not impossible. The universe is vast, and our understanding is limited. From pulsars to quasars, every weird discovery in astronomy has eventually found a natural explanation. But this star is different. It's not just an anomaly. It's a challenge to everything we believe about the cosmos. Let's zoom out for a moment. The universe is 13.8 billion years old, home to 2 trillion galaxies, each with billions of stars. If intelligent life exists elsewhere, and many scientists believe it does, some civilizations could be millions, even billions of years ahead of us. What would their technology look like? Would it resemble anything we can comprehend, or would it blend seamlessly with the natural world, indistinguishable from a cloud of dust or a flicker of light? This star forces us to confront these questions, to wrestle with the possibility that we're not alone, and that the proof might be staring us in the face. But it's more than just a scientific puzzle. It's a story about humanity, about our curiosity, our drive to explore, our refusal to accept the unknown. When those amateur astronomers first noticed the star's strange behavior, they weren't NASA scientists with PhDs. They were ordinary people, united by a love of the stars, sifting through data in their spare time. Their discovery reminds us that the universe doesn't belong to experts alone. It belongs to all of us, every dreamer who's ever looked up at the night sky and wondered, what's out there? And that's what makes this star so special. It's not just a dot of light 1,400 light-years away. It's a mirror reflecting our hopes, our fears, our endless quest for meaning. Maybe it's just dust, the ashes of a cosmic tragedy. Maybe it's a sign of something greater, a beacon from a civilization long gone or still thriving. Or maybe it's a reminder that the universe is stranger, wilder, and more beautiful than we can ever imagine. As we wait for answers, one thing is certain. This star has changed us. It's forced us to rethink what's possible, to question what we thought we knew. It's a spark in the darkness, a mystery that binds us together as we reach for the stars. And in a universe so vast, so full of wonders, that's a gift beyond measure. So the next time you look up at the night sky, remember this. Among the millions of stars burning out there, one is different. One is waiting to tell its story. And when it does, it might just change everything.